Now we are going to discuss about definition of the partial derivatives, example based on the definition. Also we are going to discuss about the mixed derivative theorem and based on that example. So let's have a look at the first limit definition of the derivative. So already you are familiar with the definition for the derivative of the one variable. Suppose you have given that y is equal f of x, curve is there. When we assume that two different points, this is our first point and this is our another point, say c plus h. But from the figure it is clear that change in y is occurs with respect to change in x. That means what we can say, delta y divided by del x. If I take limit x tends to 0, so what we are going to get? So in that case our red line goes to what exactly tangent. And that is going to be FDC, and that thing already you have done in your schooling. But now we are going to extend this concept for a function of two variables. That means we are talking about the partial derivative of the multivariable function. So here you have given that function that is z is equal f of xy. So already I have represented earlier. So here x and y is the input. Our output will be f of xy, and that is what exactly z. But suppose I want to determine the derivative. So how we can determine derivative of this kind of function? And that is the interesting part for this. Suppose if I assume that this is our x-axis and this is the y-axis, I'm just going to consider y coordinate as a fixed, that is the y0 z. That is our constant. So if I take z is equal f of x and y is equal y0, so our curve will be what exactly? So you can say, sir, in that case we are going to get this one only, because from the figure it is clear that the y coordinate is going to be fixed, so we are going to get this one curve only. And all these points on this line or curve, what we can determine slope. And that is what exactly partial derivative. So if we talk about the particular question, z is equal x square plus y square, but I'm just going to consider y is equal any constant, say a. So what I will get, z is equal x square plus a square. That means we can say that z is a function of one variable. So what we can determine its derivative. So we can say dz by dx, and that is going to be 2x. And this is the constant quantity. So what we are going to get? Only answer 0. And that is what exactly del z by del x. So we will keep in mind, for the ordinary derivative we will use d, and for the partial derivative we will use curly. That means we call it del. This is known as del. So what we are going to get, del L by del x is going to be, that is the 2x, and that is what exactly of a partial derivative with respect to x. So our conclusion says what, whenever we want to find the partial derivative with respect to one independent variable, so in that case we will keep in mind that all the remaining variable will be constant. If I suppose to consider z is equal x square plus y square plus 3x plus 2. So in that case what will be? Suppose I want to find del z by del y. That means what we are going to consider only derivative with respect to independent variable y, but actual this z is depends on x and y. That means we can determine partial derivative with respect to x and y. But we want particular partial derivative with respect to y. So I'm just going to consider x as a constant, so derivative of this one, that is what exactly 0. What about here? This is the y square, but we want derivative with respect to y, so we can say that is the 2y. And this is the 3x. 3x is a constant quantity, so answer will be 0, because we are going to derivative with respect to y. And 2 itself is constant, so what we are going to get, that is the 2y. That means whatever I'm just going to consider surface, and if I determine del z by del y or del z by del x at particular point, say 1, 2 or 1, 3, so in that case what it will be? So y coordinate is 2, so I'm just going to get that is 4. That means at this one point, if I suppose to consider 1, 2, this is our 1, and this is our 2. So our point will be like here. So what I'm just going to consider at this point, our tangent will be here. Slope look like this one. So that is what exactly our partial derivative with respect to y, and also you can consider partial derivative with respect to x. Now moving forward to the definition of the partial derivatives. So partial derivative of function of the several variable is the ordinary derivative with respect to the one variable when all the remaining variables are kept constant. So already I have said to you, whenever we can find the derivative with respect to one independent variable, so in that case we will keep in mind that all the remaining variable we will observe as a constant. So let us first consider del f by del x. That means when rate of this function change with respect to x, keeping y constant. So what already we are familiar with for a function of one variable. So what we will assume that df by dx, otherwise, df by dx is that. So limit h tends to 0, f of x plus h minus f of x divided by h, and that was a definition for the function of one variable. So in that case, what we can assume that here partial derivative for a function of two variables. So here we need to change in x. That means here f of x plus h comma y minus f of x comma y, and that is going to be what exactly definition for the partial derivative del f by del x. So we are going to consider h is replaced by delta x. Also you can assume that h tends to 0. F of delta f of x plus h comma y minus f of x y divided by delta x. If I consider del f by del y, that means we need to consider change in y coordinate. That means f of x y plus delta y minus f of x y divided by delta y. And when we take the delta y tends to 0, we will keep in mind that whenever we observe that here it's notation. So what we will write that f sub y. That means partial derivative of function f with respect to y, this is not like f of y. This is totally different. Also we will keep in mind that this is not exactly f of x. So whenever you have given the notation like that, so we will assume that del f by del x is there, also del f by del y is there. Now let us consider first question. If f of xy is equal to x square y plus xy square, then find del f by del x, that is f sub x. So now here we want to solve this question by the definition of the partial derivative. So how we can? So here this is our function f of xy. This is our definition. Now if I impose as input x plus delta x, and so what we are going to get x plus delta x whole square y plus x plus delta x into y square. This is our one bracket minus f of xy is there. So just put this one bracket, divide by delta x. But again, after simplifying, that means we need to apply a plus b whole square, that is a square plus 2ab plus b square. So what I'm just going to get this one. But whenever I'm just observe, so x square y will be eliminated. This is another is xy, so this is plus quantity, and minus will be multiply inside, so it will be minus, so it will be plus, and that is going to be cancelled out. And whenever we simplify, so what we are going to get 2 times x delta xy plus delta x raised to power 2 y plus delta x into y square divided by delta x. But whenever you divide by delta x, so what you are going to get 2 times xy plus delta x into y plus y square. But when I supposed to take the limit delta x tends to 0, so what we are going to get 2xy plus y square. This is all about the definition. But how we can determine later on directly, and that is we are going to learn. So here in that case, del f by del x is equal fx. But already we have understood that whenever we find a partial derivative with respect to x, keeping y constant, that means this is going to be constant. So I just put y as a constant, and derivative of x square is what? That is the 2x. What about here? Y square is going to be constant and derivative of x is nothing but 1. But whenever you simplify, so 2xy plus y square, and this is same as this one. That means it works without definition. Now let us consider higher order partial derivatives. Suppose we have given that the function u is equal f of xy. That means u is a function of two variables. And suppose you want to determine uxx. What do you mean by uxx? That means first we are going to partial derivative with respect to u. That means del u by del x. And still I want partial derivative with respect to x. That means whatever I have obtained, I have to apply del by del x of that. And that is what exactly del square u divided by del x square, and that is we have. Suppose you want to determine u1 y, and that is clearly partial derivative with respect to y two times, and that is going to be same. If I consider uxy, so in that case what I have to assume that? First I have to assume that the partial derivative with respect to x, and later on I have to assume that del by del y, and that is going to be what? Del square u divided by del y del x, and that is uxy. But if I talk uyx, so in that case what we can say? First I have to determine partial derivative with respect to y, and later on we will do partial derivative with respect to x, and that is going to be del square u divided by del x del y. So we will see that the order. This is the first derivative with respect to y, later on x. But whenever we look at here, so this is the first derivative with respect to which one? But we will follow from the right hand side. We will always keep in mind that this is our first and this is our second. What we can say, this is our x as a first and y as a second. How we can read this one? Del square u divided by del y del x. I have assumed that the del y first. It doesn't mean that we have to do the partial derivative with respect to y. No, first you should write and then try to understand how we can solve. So first del u by del x, and then after we will determine derivative with respect to y of whatever we have obtained as del u by del x. So let us understand its example. So here this is the given function f of xy, and I want to determine plus of del f by del x, del f by del y at this particular point. Also we want to determine del square f divided by del x square, that is known as fxx. Second one is known as fyy, and third is known as fyx. fxy, that means fyx, and this is what exactly fxy. But we will see that, we will observe that is this will be always equal, and that is also we are going to discuss in the theorem. But when in such cases it will be equal, in there are many cases are there it will be unequal. So let us see first its solution. First del f by del x. So we can say partial derivative with respect to x keeping y constant. So this is the 2x, this is a constant, so we get here only 3y, and derivative of y minus 1, this is the constant quantity, so it will be the 0. But I want to find at this derivative at 4 comma minus 5, so x is replaced by 4 and y is replaced by minus 5, and after simplifying you will get the minus 7. Same argument for with respect to y when we consider function this one. So x is a constant, so it will be 0. So here 3x is a constant, so derivative of y with respect to y it is going to be 1. And then after derivative of y, that is 1, and this is a constant, so it will be the 0. And we are going to get 3x plus. But we want partial derivative at this particular point. So whenever we put x is equal 4, y is equal minus 5, so what we are going to get? Only 13. Now we are going to determine del square f divided by del x square. That means already we have determined one time. So we will use this one, and again what we are going to consider del by del x of this one. Del by del x of this one. So let us see here. So del square f divided by del x square can be written as del by del x of del f by del x. But already we have. So what we can say, derivative with respect to x of this function, that is going to be 2, and this is a constant because we are doing derivative with respect to x, so we will get 0. So final answer is 0. But when we look at the del square f divided by del y square, so this is first already we have obtained, so just replace it and then do derivative with respect to y. But in that case always we will see that independent variables, remaining independent variable will be constant. So x or z, whatever it is, so here only x is there, constant is there, so this is the constant, and derivative of the constant quantity, so it is going to be 0. Now let us look at the del square f divided by del x del y. So what we have to follow that? First we have to determine the partial derivative with respect to y. So del f by del y. And then after we will do the derivative with respect to x. But this is already we have. So 3x plus 1. But whenever we do the partial derivative with respect to x, so what we are going to get only x. Now look at the del square f divided by del y del x. So again first we will do partial derivative with respect to x, and later on we will do partial derivative with respect to y. So after simplifying, we have obtained that this is a 0. But this is equal. In which one cases we can say that both the answer is going to be equal? Whenever we have the second order partial derivatives are continuous, and in that case we can obtain that the partial derivative will be what? Exactly same. That means we are going to get fxy is equal fyx. So now coming to the next question. If u is equal e raised to 3xyz, then prove that this one. So from the question, it should be clear that what we have to first determine. So first we will go that the first partial derivative with respect to z, then after we will do partial derivative with respect to y, and then after we will do partial derivative with respect to x. And that order we will keep in mind. So let us first understand this can be represented as del u by del z, and then we will find derivative with respect to y, and after that we will find derivative with respect to x. Del u by del x is equal e raised to 3 times xyz into 3xy. But we know that derivative of the exponential, that is the same. And derivative of the 3 times xyz with respect to z, it is going to be 3xy. Now we are trying to find derivative of this one with respect to what? Exactly del by del y. So coming to this, so what we are going to get? 3xy into e raised to 3 times xyz. That means we have to use your product rule whenever we do the partial derivative with respect to x. Why? So if 3x is a constant quantity, so I just keep it as it is. But whenever we observe, this is a function of y, also this is a function of y. That means we have to use the derivative for a product rule. So what we can say, 3x is there. Now we are going to consider this is a constant function. So in that case, we will do derivative with respect to other function. So what we are going to get, this is constant and derivative of y, that is 1. Plus y is there, then I have to derivative with respect to y of this function. But exponential is there, then I have to do derivative of this one. So what I'm just going to get 3 times xz. But whenever you simplify, so you are going to get e raised to 3 times xyz divided by 3x plus 9 times x square yz, and that is what del square u divided by del y del z. But now I'm just wanted to find your partial derivative with respect to x of whatever we have obtained, and that is we want. So del by del x of whatever we have derived, and then after we have to use your product rule. So first I just keep exponential is there, so derivative of this with respect to x, that is going to be x plus 9 into yz is constant, but derivative of x4, that is 2x, so it is going to be 18xyz. Plus this is going to be constant, and derivative of this one is e raised to 3 times xyz, and derivative of the 3 times xyz with respect to x is what? 3 times yz. But whenever you simplify, that means if you supposed to take common e raised to 3 times xyz, so what you are going to get? 3 times plus 18xyz plus this is 3yz into 3x, so it is going to be 9xyz, and this is going to be 3 into 9, that is the 27, x square, y square, z square. So it is going to be 3 times plus 18xyz plus 9xyz, that is going to be 27xyz plus 27x square, y square, z square into 3 e raised to x, y, z is that. And that is we want. Now let us see the mixed derivative theorem. So it is known as the Clairaut's theorem. Suppose you have given that the u is equal f of xy possesses continuous second order partial derivative. Already I have said in the previous next previous question. So in that case, second order partial derivatives are continuous. So in that case, we can conclude that the del square u divided by del x del y is equal to del square u divided by del y del x. That means uyx is same as uxy, and that will be the same if we get the second order partial derivatives are what exactly continuous. So let us consider this question. If z is equal x plus y raised to x, then they prove that del square z divided by del x del y is equal del square z divided by del y del x. So here z is that. So I have to determine what first partial derivative I just want with respect to x. So keeping y constant, so 1. But we know that the derivative of a raised to x is what? That is the divided by dx. So a raised to x into log a, keeping base is a, where a is nothing but greater than 0. So same argument we can apply, but we want partial derivative with respect to x. So this is what y is a constant. So y raised to x into log y. Now with respect to x, so derivative with respect to y, so it is going to be what exactly x constant, so it is 0. And here derivative with respect to y, so already you are familiar with y is equal to x raised to m, so divided by dx is what exactly m into x raised to m minus 1. Using this concept, what we are going to get, this is power and a constant because we want partial derivative with respect to y. So x into y raised to x minus 1, and that is del z by del x. But for this purpose, what I have to, first I have to determine del z by del y, later on we will determine del by del x of that function. That means this can be written as del z by del y, and thereafter we determine del by del x. So I have determined this one, so I just put it and then I do derivative with respect to x. So whenever I observe that partial derivative with respect to x, so x is there, again this function continues. That means we need to consider product rule for the derivative. So first I consider this one as a constant. So derivative of x is going to be 1 plus y raised to x is there, then derivative of this one with respect to x. So I have to apply the same rule. So what I'm just going to get to y raised to x minus 1 into log y, because here y is the constant quantity. Again, here, now we want to determine del square z divided by del y del x. So for that, del z by del x already we have determined, so just replace it and then do derivative with respect to y. So again you have to apply the product rule is there. So first derivative with respect to y of the constant one, that is 0. So I put here 0 plus. Then both the function contains y. So I'm just going to use product rule. So y raised to x is that. Derivative of the y with respect to and of this function log y. So what we are going to get 1 divided by y plus log y is that, and derivative of this function with respect to y. So x into y raised to x minus 1. But whenever you simplify, so y raised to x minus 1 it will be common. So 1 plus x log y. So what we can observe that whatever this is same as what exactly del square z divided by del x del y, and that is the same. Both are same. That means here second order partial derivatives, you can see that what exactly they are the continuous, and answers should be equal, and that is exactly we have. Now this is the Laplace equation. Suppose f of xy is a function, and this function is a solution of the Laplace equation if it satisfies this equation. That means we get f sub xx plus f sub yy is equal 0, and then only we consider the function f is what exactly? Function f is a solution of the Laplacian equation. So let us say first question, u is equal, we want to show that this is the solution of the Laplace equation. That means we need to consider partial derivative with respect to x 2 times. So I'm not going to discuss in detail, but each and every step you can see and verify that how we are going to solve. But here I just want to remind that whenever you see numerator contain x and denominator contain x, still we want to determine the partial derivative with respect to x. So division rule is that. So I just focus on this stuff, on these terms, denominator square, whenever we determine the partial derivative with respect to x. So denominator is that derivative of the numerator with respect to x, that is going to be 1, minus numerator is that, and derivative of the denominator, that is the 2x. But whenever you simplify, this is x square, this is 2 times x square. So what I'm just going to get? Minus x square plus y square divided by x square plus y square raised to power 2. This is del square u divided by del x square. But when I suppose to determine del square u divided by del y square, that means I need to first consider del u by del y, then after I do derivative with respect to y. But already we have determined del u by del y, that is we have y divided by x square plus y square. And still I want to derivative with respect to y, so we have the division rule for the derivative. So derivative denominator is square. Denominator as it is derivative of the y with respect to y, so it is going to be 1 minus y is that derivative of the denominator, that is a 2y. But when you simplify, so it is clear that x square minus y square divided by x square plus y square raised to power 2. So this is our main, because we want to show that the u is satisfied by the Laplace equation or not, and that is we want to check that. So for that del square u divided by del x square plus del square u divided by del y square is, but whatever we have determined, just replace it, and it is clear that we can take the LCM, and also you can see that this will be cancelled out, and this is minus minus plus, so again it will be the cancel out. So ultimately you will get the answer, that is 0. So directly, no need to consider this one. Also you can see directly that the LCM is what? X square plus y square raised to power 2. So what you are going to get? Y square minus x square plus x square minus y square. X square cancel out, y square cancel out. So what you are going to get? 0 divided by x square plus y square raised to power 2, and that is the same, that is V1. So this means that uxy is a solution of the Laplace equation. Thank you.